Hey everybody, thank you so much for joining today's breakout session at the DigiCert Security Summit. Today we're going to be talking about the SolarWinds attack, a cautionary tale about code signing and the practice of code signing and important controls you can put around code signing. I'm joined today by a good friend and colleague of mine, Dave Roche. Dave, what's going on, man? It's good to have you here. Dave is our product manager for the Secure Signing Manager, our manager that helps control and distribute our signing offering. And we're really excited to have Dave on with us to talk about things that organizations can be doing to tighten up their code signing practices. However, before we do that, we're going to jump in and talk a little bit about the SolarWinds attack. Clearly, this is a big attack. It's on everybody's mind. If you haven't heard of it, you need to crawl out from the rock that you're living under, especially if you're in the cyber world. This attack was massive. The magnitude of the attack, the number of companies that have been hit by this attack are massive. Brad Smith, Microsoft's president, has called the SolarWinds attack the largest and most sophisticated attack the world has ever seen. That's significant. Right now, security experts are diving in and trying to determine the extent of the attack, to figure out how many organizations have been hit, and we believe it will take months, potentially even a year, to determine the extent to which this attack has gone out. The attack is believed to have come from Russia, a state actor, with the intent of gaining intelligence on the US government. And we're going to dive into that a little bit and talk a little bit more about the attack. This here is the SolarWinds development process. This process is common amongst many organizations, most organizations that develop software. As you see here, you have the planning, the coding, the build, putting together a build and deploying the build, testing the build, releasing the build to your customers, deploying and then operating and monitoring it once it goes out to the customers. This is a common process, and SolarWinds follows this process. However, we're going to dive in and look at what happened during this attack. Back in December of 2020, the company FireEye announced that they had discovered a highly sophisticated cyber intrusion in the SolarWinds product known as Orion. The Orion product is used by many large organizations to monitor and manage their large networks. The malware that was embedded into this product was known as Sunburst, and it created what's known as a backdoor into that product. That backdoor gave the attackers access to all of the servers that were leveraging that software. Once the malware was injected, of course, it went through the build. They put together a build. They tested the build. It passed somehow, that build process. It was released, and then it was deployed to over 18,000 of SolarWinds customers. Once those customers received that update, that Trojan horse infected update package, and they installed it on their servers, the backdoor was initiated. The malware actually sat dormant for a couple of weeks before it initiated, which made it even harder for security experts to detect. But this breach was massive. Estimates say that it was deployed to over 18,000 customers of SolarWinds. 425 of the Fortune 500 businesses were impacted. The top 10 telcos in the US were all breached. All 5 branches of the US military, the Pentagon, State Department, the National Security Agency, the Department of Justice, the White House, the list goes on. Just government agencies that we're looking at there. There were hundreds, if not thousands, of private businesses as well and public businesses that were impacted. On the right here, you see the impact of SolarWinds from a stock perspective. Massive repercussions for this business. Billions of dollars lost by this vulnerability and what occurred. As we look at the attack, the more troubling part to me is the fact that they signed code that had malware in it. There are a lot of things that went wrong in this attack, and code signing is only one of them. But SolarWinds used a legitimate code signing certificate to sign a malicious package that ended up being deployed to their customers. That is the pain point Dave and I are going to talk about today. There needs to be controlled processes around those points of failure to make sure that they don't happen within your business. As I said, right now, everybody is digging into the extent of this attack. How big is it? Who was impacted? What data has been compromised? And those questions need to be asked. But I think another question that, as security experts, we need to be asking right alongside that is, what can we do to prevent these from happening again in the future? What are the blind spots that we need to be able to see to make sure that SolarWinds types attacks don't happen? And we want to talk about that today. Another thing, a lot of people are saying, who's to blame? Was it a sophisticated hacker? Was code signing to blame? Was it a code signing vendor? Was it a really bad CISO who really doesn't understand security? Was it encryption algorithms? Was it an irresponsible engineer? I mean, there are so many fingers that can be pointed, so many people or problems that can be pointed to in this attack and blamed for it. There was no single point of failure. But I think what we want to talk about today is the lack of controlled processes that led to them signing a package that contained malware. Because that's a problem that we can help you solve. That's a problem that I believe is at the very beginning of what led to a bunch of other cyber mistakes. Allowing malware to be signed with a legitimate code signing certificate. Dave and I have worked with dozens, hundreds of organizations around code signing, and we have seen some really bad practices, practices that I dare not even repeat. In the work that we've done, I've developed a list of common code signing pitfalls, practices that we've seen organizations do that they shouldn't be doing. And I'd like to share those before I kick it over to Dave and have him walk through our platform and how you can more effectively address these pitfalls. One is not having a mechanism for signing rights. In your organization, do you know who has the rights to sign particular packages? Do you know when they've signed it? Do you have controls over the rights of your signing process? That's the first one. The second one is uncontrolled distribution of signing keys. Believe it or not, I've seen signing tokens be put on USB drives and handed around freely to engineers. In a situation like that, it's really easy for a bad actor to gain access to that signing key and sign something after they embed malware on it. So having tight control of your signing keys, securing those, making sure that they're controlled. Using the key to sign all of your files. And the next one, using the same key to sign the same files across different product portfolios. You think about in a situation where you have a compromise. If you've used the same key to sign all of your files, everything in your organization is at risk and has been compromised, which requires massive mitigation. And Dave's going to talk today about key rotation strategies and how you can avoid that mistake. And then finally, the last cardinal sin is having no reporting capability or auditability over who signed what, when they signed, and having controls to be able to go and mitigate things like that. But having really robust reporting and auditing of your system is really important. While controlled signing processes won't solve all of the vulnerabilities that occurred in the SolarWinds attack, it certainly is a good starting point. I'm really excited now to kick it over to my friend Dave, who's going to walk through our Secure Signing Manager, a platform that's been designed to help organizations control processes like this. Dave?
Thank you, Mike. Yeah, so Mike teed this conversation up really nicely, guys. And what we enable customers to do with Secure Software Manager is to solve for those problems that Mike described that enterprises are finding challenging with regards to securing their software supply chain and managing the workflows for their code signing. And the things that I want to focus in on that Secure Software Manager from DigiCert can help you with is the benefits of hash signing, the ability to put account level security controls on your workflows so that they're inherited by the users who are doing code signing and managing those code signing keys and assets. the protection of the private key and the workflows around that, which help you to generate keys and rotate through them so that you're not using one key to sign everything and having all users have access to the same thing. And then also around role-based access controls, right? So not just about permissions with relation to what users can do on the service, but also getting really granular around which users and what teams can access which keys and certificates, and what they could generate and how frequently, and how that's separated then from other teams within an enterprise, which has a distributed engineering organization across multiple products, projects, countries, continents. So let's look at hash signing first and what benefits that brings. So the first thing that hash signing enables an organization to do is to keep a hold of their binaries, their intellectual property, whatever way it's compiled, whether it's an app, an executable, an installer, a container, an image, whatever that is, you don't want that leaving your enterprise without a signature being applied. And in our Secure Software Manager service, that is the case because we don't ask enterprises to upload their compiled binaries or applications to our service. We do it in such a way that our clients work with the developer teams to ensure only the hash is shared with the service for signing, and therefore your intellectual property never leaves your organization. The other benefit in that regard is around speed, right? So from a security perspective, your intellectual property not leaving is of great benefit, but because the hash is only coming to the service, it performs like a local signing, right? It's really fast, and then it also benefits from that secure process where it doesn't leave, okay? And as well as that, it's important to note that when you do that, it works the very same way as a local signing would, because we're leveraging the same tools that developers are using today. Our client is a one-time implementation, get up and running, but after that, the performance, the security is all inherited as part of the process. And we'll talk a little bit more then about permissions when we move on to the next piece. Like one of the things that Mike talked about that was a risk in terms of code signing is the private key. The private key is really critical. It's what's used to apply the signature. And Mike talked about how some enterprises are doing horrible things with regards to code signing, whereby the private key might be duplicated and stored in many locations. It might get compromised because it's left on someone's laptop. Some disgruntled employee could take it with them. There's many different ways in which private key could fall into the wrong hands. And it's all down to the fact that either customers and enterprises have to take on the responsibility to protect those keys themselves and therefore invest in hardware and maintaining that hardware, or they have insecure processes like keys being held in unencrypted software or on USB tokens. And how we solve for that is by ensuring that all private keys are protected within the Secure Software Manager product. They're generated there, so they never live anywhere else. When compliance is needed, we offer full FIPS compliance with respect to HSMs attached to our service, but we also have other alternatives for customers who need a bit more flexibility around key protection and movement of keys. Okay, so if you're recognizing any of these practices, then immediately you need to stop, okay? We're here to help. We've got a solution that will help you to improve these practices instantly, and you don't have to do so in a way that where you have to start from scratch. We're able to pull in those private keys into our service for you, and we'll be able to get you up and running with a much more secure process within hours of you getting implemented with the service. And another benefit then, when you have your keys within the service and users are accessing them, we have full visibility of who's doing that. So gone are the days whereby you have a private key, you don't know who has their hands on it, you don't know who's doing what. The keys being in the service, users have to authenticate to the service, they have to request signings. We're capturing all that. We can provide you with full reporting and auditing capability so you know who's been using those keys now that they're in the service. And you can audit yourself if something goes wrong, where something accidentally happens, if malware gets pulled in with open source software and you did a bad job on checking for that, you'll be able to check and do remediation by looking at those reports. So private key protection, really critical as part of a code signing solution and a good workflow practice. All right, so let's talk a little bit more then around role-based access controls. So not only is it about the private key access that we talked about, because as we said, if we pull in the keys to the service, we can specify who has access to those keys. We can then say that it's an individual user that might be in a build or a release role for a specific product or project. It could be a team of developers that share that responsibility. But again, gone are the days that those teams can distribute access to those keys in an unsecure way. So keys can then become responsible and available to specific users or specific teams. And what we do then is when you have large organizations with multiple teams working on multiple projects, you have keys that are specifically used to sign those projects. So there's no cross-pollination of the software that is being signed by an organization. And in that case, if one team is doing something badly, the other teams that are doing the good practices are not going to be as impacted. So it spreads the load with regards to if there is some kind of event that needs remediation, whereby not the full enterprise and all of its products are going to be impacted in the same way. As well as that, then when we talk about role-based access, it's not just about access to keys, but also being able to separate the duties of what different users within the service are doing. So you can have administrators that are generating private keys and certificates and assigning them to teams. You can have users which are specific with responsibility around signing or approval workflows. And again, you can even specify non-human actors to have a role and responsibility within the service, such as a build server where there's automation going on, and that build server has really planed back permissions to be able to do specific things as part of a release which may be fully automated. So the controls to be able to specify at a really granular level what your organization and your users can do is a really powerful piece of functionality that Secure Software Manager will offer. And finally, then there's the organization level controls. So when you don't have the ability to restrict what type of key pairs and certificates you're doing because there's no workflows built around that in terms of a solution, then you're relying on your engineers and your developers to do that. And that's not inherently what engineers are good at. Engineers are excellent at building functionality, writing code, but they're not great at choosing what's a strong algorithm to use to sign the software once it's built. They're not necessarily good at choosing, what strength the key should be. And specifically around code signing, the validity of the certificates, the type of certificate used, whether, and Mike talked about this earlier. We've seen people signing stuff with self-signed certificates. We've seen them share a single key and certificate across a large enterprise with thousands of developers, all extremely bad practices. What our organization level controls allow you to do is to specify what your users can do. So your CISO can come into your service and can see, okay, we're only allowed to use specific algorithms. The key strength that I want as a minimum size can be this. And I also want to enforce things on the workflow like approval or pre-planned signing events, which allow for what Mike described earlier in the presentation, the ability to move from the build completing and the signature happening, so that there's ample time for testing, so that things like injections of malware are not happening from an organization having very nice, clean code and then moving to doing good code signing practices. So it allows for the sequencing of that supply chain, and allows for organizations to make sure they have the controls in place so that nothing gets released and signed which has some kind of malware or vulnerability pulled into it. And I love this little image here because it talks about SolarWinds in the way that a lot of enterprises are not, right? There's a lot of good things that you can do in terms of securing your supply chain. And code signing is one of them. But it's not necessarily going to be the thing that prevents a SolarWinds type event in your company on its own in isolation, right? It's about, there is lots of good security practices that you can do, and you know, it's going to be a piece of the puzzle, but it's not going to be a silver bullet. And when we talk about that puzzle and what those pieces are, this image here outlines that nicely. Okay, so you have everything around from a compliance perspective, having the standards in place, you know, having good practices in place around encryption algorithms, passwords, secrets, you know, what your teams are doing in that regard. In terms of your source code, you know, there's lots of different security practices that you can put in place there to make sure your code is clean, is peer reviewed, and is suitable and vulnerability free. So when you build your binary, you don't have any malware that's being pulled in by a bad actor, or without when customers use open source code, which could lead to that pulling in inadvertently. And then there's the testing, right? So this is where the SolarWinds event was really vulnerable, right? They had good practices around making sure their source code was clean. They then signed it, but it was the piece in between where the malware got injected. And that is where organizations also have to have strong practices, testing the binaries that were built, scanning those, making sure that the penetration testing, the infrastructure is being checked, that, you know, when your build infrastructure is vulnerable, that is an attack vector whereby malware could be pulled in, even though your developers have all had nice, clean code. And if that is not done, what SolarWinds has proved is that the code signing piece at the end is not going to prevent that, right? So code signing has a role to play. It makes sure that when you have nice, clean code and you've developed it and you've built it properly and you sign it, that it gives you that trust to your customers that you should be able to download it in confidence that nothing's going to happen. But what we've talked about today is code signing, not just as a local signing and as just a throwaway activity where it's just something, a checkbox. We want to put the workflows around that facilitate things that happen in between the code being developed, the build happening, the testing happening in terms of all of that build. And those workflows around that remove the potential attack vectors at code signing, and even prior to that, because it can catch some of the things that were happening that should have been caught in testing by putting workflows and controls in place around that.
Dave, thanks so much for that great presentation. And to you who have joined, thank you so much for joining our discussion today on the SolarWinds attack and the importance of establishing good processes around your code signing. It's been great to be with you today. Thank you for taking the time to join. We hope you enjoy the rest of the Security Summit. Have a great day.